Hello and welcome to Game On Episode 4. I am Todd Kerpelman. I'm a developer advocate here on Play Games.
Hello, my name is Haku Matsuda, Android developer advocate for game technologies.
And today we're going to be talking about OpenGL ES 3.0. Before we get into that, let's jump into some news and updates. Not a whole lot this time in terms of news and updates, except that we've got more info on CloudSave. This guy, Tom Fitzgerald, who happens to be a Googler, emailed me earlier today and said, "Hey, I saw your show." So we have at least one viewer. Thanks, Tom. About CloudSave, and I went and added it into my own HTML5 game. And he put up a YouTube video where he sort of talks about the process, shows you his code. It's pretty quick. It's all of about 3.5 minutes. But if you're at all interested in doing more with CloudSave, particularly in a web-based game, I encourage you to check it out. And I suppose this is something that's important to point out is CloudSave, it's not just for mobile games. It's also very useful in a browser-based game. Local storage is very cool for HTML5, but it does have the disadvantage that you basically can't keep your storage between browsers or obviously across different computers. That's why it's called local storage. And so if you have to deal with a player that is either playing on different browsers or on different computers or on a tablet and a computer, again, look into CloudSave, and you can look into what this guy Tom has done in his YouTube video. So with that, let's get into the main subject of today's talk, and that is OpenGL ES3. Hakuro, you're our expert, so I'll let you take it away.
Okay, so for today, I'd like to introduce you a new API in Android 4.3, OpenGL ES3. OpenGL ES3 is a superset of existing OpenGL ES2 so that you can use your existing game code for OpenGL ES2 without any changes. You can adapt some of the advanced feature set of OpenGL ES3 and get benefit of them quite easily. In ES3, it supports multiple new features which can be categorized into 3 areas: performance, quality, and flexibility. For performance, ES3 supports several advanced features such as the transform feedback, geometry instancing, occlusion query, and multiple rendering target. The transform feedback is a quite useful feature to the math in GPU side rather than CPU side. You can update your vertex buffer object entries directly based on the math done at GPU without involving any CPU. This one is good for use in the particle engine or such as the skinning done in the GPU with multiple rendering paths. Also, geometry instancing is a feature that can render multiple instances of geometry with just one API call with different parameters. The feature is good for both CPU and GPU performance because you don't have to call API multiple times, and also GPU has hardware support to handle them efficiently. For games that render the same object multiple times, you should use that feature. Other features such as MRT, which can render to multiple render buffers at the same time, and occlusion query, which can check GPU if geometry is visible or not. They are also great to reduce both CPU and GPU load dramatically. Let's talk about quality side. In ES3, it supports ETC2 as the standard texture compression format. ETC2 supports the alpha channel and produces better quality in 4-bit per channel, which is quite smaller than regular texture format. It replaces ETC1 and various other GPU-dependent formats like DXT, so that you can finally use one single texture compression format in your games with GLES3. Also, as an optional feature, you can have ASTC, Adaptive Scalable Texture Compression texture format that is much more advanced and better quality texture format. STC is supported in some GPUs such as Mali GPU. ES3 also supports floating point textures so that you can do real high dynamic range rendering in your games, not a fake HDR. For flexibility side, it supports features like non-power of 2 textures so that you can have arbitrary dimension of the textures, not limited to the power of 2 size. And it supports more render target format and texture format as well. Also, you can attach depth buffer as the texture. In ES3, shader language is also updated to GLSL ES 3.0, which support integer and other new language features. So in general, ES3 supports comparable feature set of desktop version of OpenGL 3.1 or DirectX 10, except support of geometry shader, which can produce more triangles after a vertex shader stage. So that with GLES3, you can port your games quite easily to mobile platform. In performance-wise, mobile GPUs with GLES3 support has a comparable performance range of low or middle-range desktop GPU, which is quite surprising for me because mobile GPU works on 1/10 of low energy usage. Currently, SDK 18 and NDK R9 both support GLES3, and all of Nexus 4, 7, 10 supports GLES3. Please try new feature set of GLES3 and enjoy them.
Well, cool. That all sounds very exciting. As
Yes.
somebody that likes good graphics in my games. I wanted to ask about when you talk about some of the performance improvements. So geometry instancing, I think I understand. Like if I had, I don't know, 50 cars in my game that all were essentially the same, I would essentially only define one car model and kind of save on a whole lot of geometry passing by saying just reuse this car model in multiple places.
In GLES2, you had to call the API 15 times in this example, but with GLES3, you can render 15 cars at the one single API call.
That's cool.
Yeah, in Android, basically API call is not quite cheap, so that it's a great performance win.
Gotcha. Now, could I have different textures or different colors on top of these cars and still take advantage?
Yes, exactly. So you can have different parameters like a transform, texture UVs, and any other parameter can be different by model instance.
Gotcha. So I feel like at one point there was a lot of games that featured like crowd scenes where all of a sudden they were drawing a lot of people. They're basically taking advantage of this technique and kind of putting different skins on the same model so that you get the impression of a lot of people.
Exactly.
Okay.
Exactly.
Oh, that's very clever. I still don't quite understand what transform feedbacks are. Is that something you can explain further, or is that really just like?
Yes. So in general, in ES2, the transform or GPU mask is just one way. So CPU issues a render command and the GPU do some work and render it. That was it. But in OpenGL ES3, you can feedback the output mask of the GPU into the buffer again, so that you can update the geometry skin or you can update the particle position inside the GPU and write back to the buffer, so that in each frame you can do the math completely in the GPU side.
Okay, that's starting to make more sense to me.
Yes.
All right, so like would that work if I had to say perform the same kind of transform and scale to multiple objects? Could I take advantage of that feature there?
Exactly.
Okay, and MRT, multiple render targets. Is that like the feature where I can kind of like sometimes in the background you might see a TV that's showing kind of what's going on in my game? Is that technique? Or is
it's mainly for the multiple paths. In the GLES2, to do the multiple path rendering effect, you had to render the normal at this path and the color at this path, and that's the final gather path. You need to fetch these render result at the final gathering path. But in the MRT, you can output two different values into different target.
Okay.
So that you don't have to draw the same thing twice, but just once. And at the final gathering path, deferred rendering path, you can get two results at the same time.
Gotcha. So like what techniques would you see making use of MRT?
Well, with the deferred rendering technique is render several parameter of object into several buffers and gather at the final path. You can get the great benefit of MRT in terms of the performance.
Okay.
Yes.
Okay. Well, let's see. I think let's move on to a demo. We've got a cool demo that was put together by the good folks at Silicon Studio. I guess this is, I don't know if it has a name, except maybe Rings and Jewels, that we showed off at the Nexus 7 launch event just last month that makes use of some fairly cool
that's cool.
ES 3.0 techniques. Let's bring this up. This is recorded on a new Nexus 7 device that I think Dan said I could keep after this session's done, right? He's laughing, which I think means yes. So, all right, we've got these very cool shiny rings, and I can click this add button and add in a few jewels, and they fall down and knock over the rings, and it looks very cool.
Yeah, physics simulation is in the CPU side, and it's really cool physics.
Yeah, nice. It's nice physics. So what are we seeing here that's being done by GLES3?
Well, in the GLES3 mode, they are using a floating texture so that everything is rendered in the high dynamic range.
Okay. I've noticed there is a switch here. I can switch ES3 on and off, and I notice when I turn it off, there's a few things that happen. One, you don't kind of get the nice shine on the rings like you do before. You kind of get a little bit of lens flare off the ring reflections, and that goes away. I've also noticed the table texture looks much blurrier. What's happening there?
Right. So in the fake HDR mode, which is with OpenGL ES2, everything had to be in the range of the 0 to 255, which is 1 byte range. But in the OpenGL ES3, it can have the float dynamic range so that it can show more details on everything.
Gotcha. And so that's why when I turn on GLES 3.0, we need a cooler code name for that.
Yes.
And that's why the table suddenly looks so much more detailed.
Right, yeah.
We're able to suddenly spend more kind of basically more data per pixel on.
Right, precisely.
Okay. And I noticed something also seems to be happening with the gems. I'm not quite sure. Is it somehow doing different type of refraction, or when I switch on and off ES 3.0, I noticed that there's something that I can't quite articulate with the gems where they look much better with it on, and I don't quite know what's going on there.
Yes, so basically it's also thanks to the high dynamic range. So the edge of the jewels can be sharper and the reflection can be clearer in the GLES3.
Gotcha. All right. Well, cool. So, all right, I could play with this for a long time, but I won't because we have other stuff to do in our show.
Cool.
But excellent. So let's see. Yeah, other Q&A. So in terms of what devices support OpenGL ES3, you had mentioned the Nexus 4, the new Nexus 7,
New Nexus 7, yes,
and the Nexus 10.
right.
Are there other devices out there? How would I know if a device supports?
Well, in general, as of today, GPU from Qualcomm like Adreno 320 and 330 should support the GLES3. Also, GPU from ARM Mali T600 should support the GLES3.
Okay. Well, maybe that brings us to our third question. So if I'm a developer and maybe I want to add in some of this OpenGL ES3 techniques to my game, but at the same time, you obviously want to support a large range of devices. What do you do with your code to make sure that you can still, basically to make sure that I can kind of have an engine that looks really nice on the machines that support it, but doesn't crash or something on the engines that
Yeah,
don't?
that's a great question. So
Thanks.
yeah, as of today, almost of the Android device, like 99% of device supports the OpenGL ES2, but just a fraction of percent supports the GL ES3. So
Obviously, that number will probably grow.
yeah, in
now that
future
we've announced
rapidly.
it.
Yeah,
Yeah.
that's my hope. But as of today, you need to have the two code paths. One is for GLES3 and another one for GLES2. Also, you can check the existence of some OpenGL GPU extension so that you can, even with the GLES2, you can still utilize some of the advanced feature set available for GLES3.
So I might, for instance, I don't know, some hardware manufacturer might have a chipset that officially supports GS2, but might support one or two features from the OpenGL ES3.
Right.
And so that's something that a developer could check on a feature-by-feature basis.
Yeah, exactly.
Okay.
So it sounds like complicated, but it's kind of like a PC-like gaming model. So in the PC, you need to check all of the feature existing to utilize most out of GPU hardware, so that you need to do the same thing in Android device.
So it's really not much different than what a lot of PC developers are already
Right.
doing today.
Right.
And maybe that brings us to our second question, which is, I might decide as a game developer, this sounds like a lot of work. Maybe I'll find an engine to do this for me. Are there engines out there that support this already?
Yes. So many of game engines like Unity and Unreal Engine already support the GLES3.
Okay.
So that for me, GLES3 is really easy to use, but for somebody it might not. So that you can still use the game engine to support the GLES3 advanced feature set.
Okay. And I guess actually that might bring up good segue. We do have one other demo, which is the Unity engine, and I suppose maybe some of this really isn't so much showing off OpenGL ES3 features, so much as kind of showing how nice things look on the Nexus 7. But it sounds like they are probably doing a fair amount of OpenGL ES3 performance improvements.
Yeah, exactly. So they
we're
are
gonna-
already.
We're going to run this. This is called the Chase. And I noticed they're showing a fair number of features going on here in terms of atmospheric scattering, a 4-kilometer draw distance. They think they talk about yes.
Yes, so that they are using really high polygon model in the entire scene. It's rendering more than 250,000 polygons in that scene, which is incredible high number in terms of the mobile gaming. Also,
Yeah, I mean this looks like a console game.
yeah, exactly. And also they are using some advanced feature set of the OpenGL ES3 for performance improvement mainly. So that with the ES2 devices, the demo still works, but with the ES3, it can utilize the feature set of the occlusion culling to check if sun is visible in the scene. And also it's using the geometry instancing rendering so that it can benefit of the performance of the GLES3 feature set.
All right, well, that's very cool. That's neat. My biggest complaint with this demo is I can't figure out who the good guy and who the bad guy is. They both sort of look
Yeah, but
kind of sinister. They're both, kind of shooting in amongst all the civilian traffic, which really isn't all that safe. Maybe neither one is actually the good guy.
Maybe.
Maybe. But I suppose that's a little off topic. So awesome. This looks great. I can't wait to try out more games on this device that Dan is letting me take home. So thanks again, Dan. And we'll bring up our final slide, which is if you want more information about OpenGL ES3, this is basically our our OpenGL page on developer.android.com.
Yes. Also, we are releasing some more sample code for NDK and Java SDK for OpenGL ES3.
That would be fantastic.
Yes.
Awesome. All right. Well, thank you very much for joining us.
Thank you.
Thank you out there for joining us, and we will see you in a couple of weeks with our next Game On session, if we don't get canceled. All right.